Okay, we're back for another exciting unscripted CQL language demo. And actually, this time I'm going to go right into the demo directory where I'm standing right now. And here, let me just clear this mess and we can see what's here. And I'm going to walk through these files because they're actually going to cover some pretty useful stuff. And basically, it's going to show how you can get data out of CQL and back into the C world. And you could maybe kind of already have guessed how this is going to work. If you watched the previous one, you would have seen that there's lots of very straightforward looking .h files that are associated with whatever output you have, and you can tell what the signatures of your methods are, and all of those methods have very simple signatures that you could call with straight C using the usual currency that you have from SQLite. And you get things like statements and databases and whatnot. But actually, you can avoid a lot of those problems and just kind of get direct access to data in a fairly straightforward way if you start using some of the additional features. So this is a little demonstration program, and I'm just going to run it. And then you'll see kind of what's going on, and that's going to do the build. And this does a bunch of stuff. It ends with Mandelbrot. This is the Mandelbrot sample right from the SQLite documentation. But you can see it also does a bunch of things where it prints some rows and stuff that it got from various different places. And I'm just going to walk you through exactly how that happened. And that should be kind of helpful. And then we'll maybe see some automation features. But I want to start with result sets kind of as a place to start anyway. Okay, so let me look at the SQL because that's actually pretty clear. Okay, so first we have this procedure called make mixed, which is going to make a table called, creatively enough, mixed, and it's called that because it has all kinds of different data types in it, and that was just to make the sample a little bit more interesting. So there's a bool, there's a long integer, there's text, there's a regular integer, there's a real. Okay, and here's a thing called load mixed, which does really very unremarkable things. Okay, insert some values into that table that match, and it first deletes the contents of the table. You can see right here. Okay, and then just some straight up insert statements, pretty boring. So you could imagine first you call this, and then you call this, and then you have some data in the table. Here's a procedure that does something really even more exciting. It takes an ID and a rate and updates the rate in the row that matches the ID. Okay, so that's, again, really super straightforward. Here's something a little bit more exciting. There's an attribute here that says the identity is ID and code, which I just made up for this demo. And that means those are the two columns that sort of uniquely identify an item. In this case, I made it ID and code. And actually, you'll see I didn't even make a primary key in the table or anything like that because just demo. But presumably, those would be the things that were in the primary key. So pretend it's in the primary key. Okay, and so that tells us something about what the identity is going to be for those things. And this is a very simple procedure. And you can hear for the first time, you can see we're doing a select. Okay, and so this is going to return something that is going to tell us, all the columns from mixed and order them by ID and get only lim columns. Okay, limit lim. All right, and look at that. Oh, here's an exciting one. We don't have rtrim in the standard library. Actually, I'll be fixing that soon. But you can manually declare anything that is supposed to be a function that appears in select. So in the early days, before I had most of them covered, you could just manually declare whichever ones you happen to need. And if you add any extensions, you can use this form here, declare select function, which means that function is legal in the context of SQL. So it's something that's known to SQLite, and here we're just telling it what the signature is, and that will allow rtrim to appear in this thing. And this is pretty much exactly the source of the Mandelbrot sample that you can get right out of the SQLite documentation. But it has this other funky thing here where once we do the select, we actually put it in a cursor instead. See here we do declare C cursor for, and then this is the statement that is pretty much right there in the docs. I could walk you through that, but that's sort of neither here nor there for purposes of the language. Suffice to say, this uses some interesting combinations of common table expressions to create a pipeline that will produce some Mandelbrot set. Okay, and this gets the rows. We just loop fetch C, begin, call printf, and so forth. So each line gets printed out. So this does the print, and you saw already what the output was. So let's look at how some of these things get used. Okay, that's going to be important. So remember, we have something that does make mixed, load mixed, update mixed. Okay, and the demo is going to do all that stuff. Okay, so let's now look at demo client. And we'll see what that all looks like. Okay, so there's some super cheesy error handling here. Okay, so this underscore E basically just says, hey, if the result is anything non-zero, then go ahead and fail. Okay, it prints a failure message. And then so then we have this E of X is the same as underscore E, and SQL E is just assuming that the result is supposed to be SQLite. Okay, so that lets us use E and SQL E, and we'll get a useful message if anything fails, which is really kind of boring for this example. But all right, let's see if we can let's search for main, and we'll start there. Maybe we can learn to type. Okay, great, perfect. Okay, so creating and reading from a table. So first we make a database. It's an in-memory database. Okay, you'll recall from the last demo that I actually cribbed those lines. And then we have, look at this, get result set, get mixed result set, ref, result set, ref, copy, and updated. And there's some funky stuff going on here. Okay, but look, our first call is to make mixed, passing in the DB. Okay, and that's going to create the table. Then load mixed, which is going to put some stuff in there. Then we're going to call get mixed fetch results. Okay, and you may recall there was no fetch results method. We just had get mixed. So what's going on there? And somehow we're gonna, get a result set. That's the output, passing in the DB, and we're passing in a count. And so what's going on there. Then we make a copy using get mixed copy. Where did that come from? I don't know. Then we do an update. Then we do a get mixed again, and then we do some stuff for printing. We have this little helper print result set. And also there was a copy in here. No, I mentioned the copy. So there's some stuff, and then there's the updated version. Holy schmoly, there's lots of stuff going on here. Okay, and then finally we're going to do Mandelbrot. So really, to make any sense of this, I think we're going to have to look at some of the code that was generated, which was the whole point. But you can see this is just fairly straightforward boilerplate, and I'm not going to look at the thing that prints the result set just yet. I think it'll be helpful to look at all the stuff that we got. Now, if I'm a clever man, well, here, let me just show you what's going on in demo.sh, and then I won't have to do anything magic. Okay, so everything is going to go in the /out directory, and it turns out there's some make steps in the standard make file that make the demo binary, and then we run /demo. Okay, so we should look in /out. Okay, and I think we'll find demo.star. Okay, and great. We don't need the dsym. So let's look at the .h file first. That'll tell us about the prototypes of the functions we're allowed to call after the compilation. Wow, look at that. There's a lot of them. Okay, so this one's pretty straightforward, right? Here's make mixed. It just takes a DB. Okay, no surprise there. It returns a SQLite return code, which I abstract as SQL code. And then we call make mixed. Here's load mixed. It's the same. So these are kind of what your imperatives look like, right? And update mixed, very similar. It takes a DB, takes an ID, and it takes the new rate. Again, no problem there, right? And then we have some things here. CRC get mixed. That's actually used for profiling. And so I'm not going to talk about the CRC right at this moment. There's a string reference for the procedure name, get mixed. Okay, and then there's some funky stuff here, okay? So get mixed is the thing that produces the result set. So we have this method, CQL result set type decl. Okay, no, this isn't the method. This is the type declaration for the result set reference. Okay, there's a little macro that helps us with that. These are actually all the same data type underneath the hood, but we create a new unique type with a unique name using this form, just so that you'll get errors from the compiler if you mix and match. But actually, underneath the hood, they all look the same. Okay, so here's the first of the interesting things here. Look at that, get mixed, get ID, okay, where it takes a get mixed result set ref and a row number. Okay, so this is going to give us the ID for any given row. Great, okay. Get name, same, takes the result set ref and a row. Okay, so these are a bunch of getters. Okay, here's a bool getter, here's the in64 getter, here's the flag getter. Okay, and oh look, the flag is nullable, so there's an is null and a value. Oh wait, the code was also nullable, so there's a get is null and a value. Okay, and the rate was nullable, so there's a get is null and get for the value. Okay, and then here we have this thing that you give it a result set and it gives you back the count. Fabulous. And then we have this new method, get fixed fetch results. Okay, so that looks like it's going to give us back one of these result set refs. Yes, sure enough, result set ref, nullable, non-nullable star ref, so a star star. Okay, so you're going to pass the address of your result set ref and it's going to fill it in. That makes sense. And it takes the lim parameter. Oh, here, let me clear. There's lim. Okay, so that's obviously cribbed from the getter proc that we wrote. So our lim ended up here. And then we got these extra sort of hidden parameters here, to the DB and the out parameter for the thing. Okay, and then, okay, here's a method that can do a copy, okay? So this basically calls a standard helper to do the copy, so it's all macroized, okay? So you call this method and it just does the appropriate stuff for you. And then you can do some other stuff. You can take a row and you can hash it. You can take a row, two rows from different places and see if they're equal. And it calls rows equal. And then here's rows same, okay? And same checks just the identity columns, but is otherwise the same as rows equal, has the same kind of signature. So in this case, we marked 2 columns. You'll recall we were using ID and code as the equality ones. So sameness is an ID check, whereas equality is a full comparison. Using sort of is logic. And wow, that's it. And then here's the one for printing out a Mandelbrot, which has no result code. Okay, so every time you make a result set, you get a pile of this stuff. You get like a bunch of getters and setters, and you get an abstract data type for the result set. And then you can just ask for each kind of column. Okay, so that makes some sense, right? All right, so let's look at some of this code and see how this actually works. Let's see what the C code has to say. Okay, so it's gonna, as usual, it echoes all this stuff. It echoes back what you entered. So here's the make mix proc. We saw that before, and here's the code for it. This should be really not surprising to anyone. It just immediately does an exec of whatever you typed. Okay, ID integer not null, name text code, long flag, etc. So this is pretty much just verbatim. It's been normalized a little, but it's verbatim pretty much what you typed. Okay, and load mixed is exactly going to be the same. Okay. Here's the delete, and then here's the first insert, and the next insert, and the next insert, and the next insert, and the next insert, and that's it, and return the result code. And update is going to be exactly the same. Okay, there's the 2 parameters, right? Look here, parameter, okay, and the implicit DB. And again, we're going to prepare an update mix set rate, where ID, okay? So the rate is going to be what we set it to be, and the ID is going to be what we set it to be. And we bind rate and ID, okay, as a double and an int32. And they're both not null. Great. So that's easy. And then there's just error checking, and then we do this step as usual to execute it. Then we finalize our statement one way or the other. Okay, so the actual exciting one is get mixed, okay? And so here now we're defining what the shape of the row coming back is, okay? And that's kind of, this is our select star. So ID, code, flag, rate, name, okay? No surprise there. There's a string literal for the name get mixed, which is the original underlying name of the proc. And this performance index, that's where the CRC is actually going to ultimately end up going. So I'm not going to worry too much about the performance hooks right now. That gets a little complicated, and it has nothing to do with sort of your normal day-to-day accessing of the stuff. Okay, so here's the implementations of the getters, right? Here's get ID. Okay, and it's just going to do result set get data, okay, casting everything to a result set ref. And that gives us the row that we're on, okay? And so that does a nice little computation for us. And it knows how long the, it knows, this gives you back the base pointer for the data. And we know what the shape of that data is. It's get mixed row, so we can just use data subrow .id, and likewise for name. And then for code is null, recall that that nullable types are a pair of is null and value, small struct. So here's the ones for the code, here's the ones for the flag, Here's the ones for the rate. See, that is null and value. Okay, so just, right, it's just a simple rectangle, data sub row dot rate dot value. So very dense, one allocation. That's kind of nice. Okay, here's some metadata that tells us the shape of that row set, which is helpful for cleanup functions and other kinds of jazz. Importantly, it's useful to know which ones are strings. Okay, and in fact, you may have noticed something interesting. I'll go back here and just mention it real quick. Notice that the name is last, even though the name wasn't the last field that was mentioned. All the reference types are pushed to the end of the struct in terms of layout. And that helps us for a number of reasons, because they're in 64. So to help with padding and keeping those things small, that helps us. But actually, there's a more important reason. We want all the references to be together, and so we just need to know how many of them there are and where they start. Okay, so here's those identity columns, ID and code. Okay, here's the offsets of the various fields in the structure. So for metadata processing, it's easy to find any given field. There's just this little array here that tells us there's 5 columns, and here's the offsets of the columns within the struct. Okay, great. So these are the offsets and these are the data types. String in64 bool double. Okay, and notice that they're in logical order here. Okay, so even though name is going to be at the end of the struct, it's still the second column. So well, that is ordinal 1. You get the idea. This is 0, this is 1. But the offsets take care of putting it in the correct place in the struct, even though it's still in order, the order you specified. So you'll get the columns back in the order that you asked for them. Great. Okay, so here's a little helper that gets the count. We saw that in the .h file. And now we see this other thing. Here's the new one. This is the one that actually builds the result set. Okay, so it's taking the arguments that we saw, okay, the database and a reference to stuff the result set in, and the limit. Okay, and what's this guy going to do? Okay, he does this profile start stuff, and I said we weren't going to talk about that too much. He calls get mixed. Okay, and get mixed is sort of the proc you wrote. Okay, and the procedure you wrote takes a database, returns a statement, and takes the limit. So this whole fetcher is always automatically generated. Okay, but the underlying guy is this one, get mixed, and it corresponds to the code you wrote. Now this little fetch info structure has a spot for the DB and the current statement and an offset to the data types, and the column offset, the count of references, and the offset of the first reference. Okay, so this tells us if we need to release a row, then there's one reference in the row and it starts at this offset. So if there were 2 or 3 names and they all needed to be released when we release a row, you know, this would just say 3. This would say something like 3, and the offset would probably still be the same, whatever it would be this constant, but that constant would point to whatever the offset is of the first thing. So what's cool about that is when we need to release the row set, we can just walk through all the rows, and for each row, we can start at the offset of the first reference and march along, you know, to pointer, 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 pointer. So without having to record where they all are, just by knowing that we put them all together and at the end, and we know how many of them are, we can very economically find all the pointers that need releasing in a whole result set, and it costs us only just these couple of bytes. Okay, here's the identity columns. That's the little array that we saw before. This is how big a row is for the helpers that might need with the row set. The CRC of the helper function, and then the place where we're supposed to store the performance jazz. Okay, so this little bit of metadata lets us call CQL fetch all results, okay, which basically will walk this statement, okay, and walk the statement here, okay. So we passed it this whole info bundle, right? It's going to walk this statement here, and it's going to keep fetching results until there are none, and it's going to accumulate that rectangle, and this metadata tells it exactly what it needs to allocate, how big the rows are, what the offsets to all the columns are, and whatnot. So it'll be able to put those data in exactly the perfect place every time. So what's cool about that is no matter how many of these fetchers you have, they all look exactly the same. They're all exactly a call to CQL fetch results. And the only code there is, no matter how many columns there are, no matter how complicated the fetching is is this same boilerplate initializing of this array, which is just basically a few constant assignments. So this is actually very economical, and it's a, so it gives us a nice clean way to create a result set. And this guy does all the binding, and actually, sorry, not the binding, the column fetching. Okay, and it does the column fetching using the data types that were indicated in the arrays above, and it calls the appropriate SQLite helpers to extract those. And of course, it knows which ones are nullable, so it knows whether it should ask if the column's null before it fetches it and all that jazz. And if anything goes wrong, the result goes right back into this RC thing, and it's returned here. So the beauty of it is that this thing will return exactly the right result set. It will either allocate it or free it, and everything comes out right. So there isn't even any control flow needed in all of these get results helper procs. Okay, so get mixed itself, okay, this is the thing you wrote. Super simple, okay? This looks very much like one of the procedures that we normally write, like all the other ones. It's a little bit different, okay? So the difference here is this thing has a select statement, so there is an implied statement result, okay? That's right here. This is the implied out parameter for that statement. This is the argument you specified, lim right here. Okay, so that's the limit that's going to be bound. And the DB is the database that it needs. Okay, perfect. So all we're going to do is the usual prepare. Okay, there's the select statement, practically verbatim, except in this case, there's an operand in limit. Okay, so then we're gonna call multi-bind. So this, of course, it could have been anything, right? Any select statement, however complicated, with however many variables, arguments, whatever, it would have been the same. There'd be more of these rows and more question marks, right? And there could have been computation or whatever before the select, but if it ends with a select, then you'll get this. In fact, it doesn't actually even have to end with the select. The last select that you ran becomes the result if there was one. If there's more than one, they have to be exactly compatible. So that is, they have to have exactly the same number of columns and types of columns and names of all the columns. So you could have several different ways of getting the result, and you have control flow to pick them. Whichever select is the last one to run owns the statement. Any other ones get freed. Typically exactly one runs. In fact, the 99.9% is that there's exactly one select statement, and that's all there is. This is a very common type of stored procedure. And then we have the usual cleanup. Okay, Mandelbrot, this is just really super simple, okay? Very similar to before. So we have some helpers for the cursor, just like we had in the last demo. Here's that big query where we're going to do the prepare. We get a statement. We get a statement from this guy, and then we start fetching, and then we print each of these guys, and it's just a single piece of text. So, and here's our same loop fetch structure, just like last time. This is the fetch part, and the for obviously is the loop part. While there's a row, we stay in it. And if there is no row, then we're going to break. And that's it. Really pretty straightforward. Multi-fetch is set up so that if there is no row, it's a big no-op. So the control flow can be a little bit simplified. It saves us a few ifs and stuff. You could look at these helpers. They're really very, very straightforward. But it's set up so that it looks at the RC here. So in the event that the RC isn't SQLite row, it's just going to do nothing. And then this is going to break out and do SQL cleanup. Great. So that's all of this. And you can see it's very similar to what we did in the last demo. And all of this, we got our statement using the CQL prepare, and the statement went into the variable named C, and it's called C because that was what we declared the cursor to be. So you can see the cursor has two parts. It has a struct that's going to hold data, and it has the statement, and the statement lives in the variable that matches the cursor name, and the row structure lives in the cursor name with an underscore. Great. And so that's pretty much it. And very straightforward. Okay, so with that in mind, let's have a quick look at the demo code again. Okay, we're going back to demo. Now let's have a closer look at demo client. Okay, so print result set, we can already guess what that's going to look like. Okay, we're being passed in the result set, get mixed result set ref. Okay, there it is, our result set. And then we have our data, an isNull and a value for the bool, an isNull and a value for the code, a string ref for the and an ID. And we're going to just loop over I until we get up to whatever the count is. And at each point, we're going to try to get the ID, and then we're going to try to get the isNull, then we're going to try to get the value, and this is going to give us a null if a nil value if this is null, then you get whatever 0 maps to. But in principle, you really don't want to be looking at this if this is null. Okay, but our thing is really very straightforward. So, right, code is null, code value, and name, and then we just do this big fat printf. Okay. And we report all those different things. And yeah, that's it. That was our printout. And so we're going to do that a bunch of times, right? We're going to do the load, get results. Then we're going to make a copy. Those should be the same. Then we're going to update. Okay, so we set it to 1234.5. Great. Do this update mixed. And then we're going to get again. And then... okay, and we've gone over this before. We're gonna we do have some expectations here, so it's doing a little bit of testing. So it's making sure that the counts are exactly the same. If this is false, we get an error. So this is kind of like expect, if you will. Okay, and then we just print them out. And then we also verify that equal reports that they're all equal in the appropriate places. And then we do the same deal with row set same, verifying some rows for sameness. 0 should match 0, 1 should match 1, and 0 should match 1. That's the way we set it up. And then we're done. We return our stuff. And look, we forgot to close the database, but lucky for us, it's just an in-memory database anyway, so it's just going to get dropped on the floor. But that's actually a memory leak in this program. So if you were a good boy, you'd be doing, you know, a SQLite, you'd be doing a close here, right? Okay. So you guys do a close. Don't be like me. Okay, so let me look at the output again. Well, it was actually still even on the screen. Okay, so now it makes some sense, right? Here's row 0, 1, 2, 3, 4. And here's the copy 1, 2, 3, 0, 1, 2. And then here is updated 0, 1, 2, 3, 4. And oh, and for the copy, we didn't copy the whole thing. So that's why we get only 3 rows, right? We can look at that. And there's our Mandelbrot set, but here, let's make sure that's as it should be. Copy. Copy index and copy count. There we go. Copy index is 1 and copy count is 3. Okay, so we skip the first row and we skip the last row. So that's right. So there should be 3 rows. Okay, and we can actually verify that row 0 is now what row 1 was. Correct there. Okay, row 0, so 2, 3, 4, 2, 3, 4, 14, 15, 19, 14, 15, 19. You get the idea. Okay, perfect. So that's a little demo. And it shows us some pretty cool stuff. It shows us how from C you can call pretty much any proc that you want. And in fact, the signatures of the procs are really very simple. So you can actually write a procedure with weird logic. Maybe you have some funky logic or some external helpers that you need to call in C. If you make a C function that has the signature that a stored proc has, you can declare that you have such a stored proc. And it'll just call the C, right? And it'll just work because the arguments will match. Even the .h file will match. The .h file that CQL generates will match the .h file that you created. And so you can just call it. So if you want your own weird, atypical thing that maybe uses something that's very difficult to express in CQL, you can just call out to C. And from C, you can call back and you can see these are very, very missable. Now, as we'll see, there's some JNI available to get and manipulate with result sets. I won't go over that today. There's Objective-C wrappers, and it's actually very easy to make additional wrappers, as we'll see because there's JSON output that tells you the signatures of all these things. And from the JSON, you could actually recreate the .h file or the .java file or whatever you wanted. Okay, so I want to do one more thing that's sort of interest. I'm going to go stand in the sources directory because that's where I'm used to standing. And so now that you've seen what result sets look like, okay, I was really a big fan of making it possible to do really good quality testing on stored procedures. So I'm gonna use my usual x.sql. So here I'm gonna create this table, create table foo, okay, and I'm just gonna make it I don't know, a integer not null, okay, and how about bc? This will be fun. Okay, there. So this could be a lot more generic. Okay, great. So suppose we have a table like this, okay? And now I'm going to write a procedure that, I don't know, inserts some rows. Or how about we start with selecting some rows? That's good. Let's do that. So if I wanted to, you know, get foo, okay, and I might write a procedure something like this. Probably it would have some parameters, but I'll just keep it simple. Okay, select star from foo. Okay, great. So with this, I could read all the foos, okay, and you know, presumably do something with them in C. Okay, so that's fabulous, and so we can just let me just verify that that in fact compiles. Okay, and I have to do dash dash in, and I'm gonna do dash dash cg x.h x.c. Okay, so perfect. We can see, you know, the usual thing. Here's our foo. Here's the getter for A, B, C, D. You get the idea. Okay, all our getters are gonna be there and so forth. So there's get A, get B, get C, get D. There's the count. Okay, so you could imagine calling that guy. Okay, great. So that's kind of cool. Now, if you wanted to test this, okay, suppose you wanted to fake the results, okay, because in a test you want to, you know, this might be some complicated logic, and maybe getting the data actually into the foo table is very complicated, you know, could have bunches of different stuff. So you might say, no, look, I just want to make a result set that looks like the one I'm going to get out of foo, okay, so you say, okay, I want to do create procedure, you know, mock foo or something like that, okay, and you want this thing to produce a result set very much like the one that you had above, okay. So you think to yourself, okay, well, what am I going to do? Okay, well, I need a temporary table or something, right? So, all right, okay, well, I'll do this. Maybe I can copy this code, okay, and then I can say create temp table foo, you know, foo underscore t, and then I can do like, oh my God, okay, need to insert some data in here. So I'm going to put, you know, maybe I'll put insert into foo t values, you know, 1, 2, 3, 4, okay, and then okay, I don't know, maybe 5, you know, 7, 5, 6, 7, 8, okay, 2, I can't stand it anymore. Okay, and so here's my mock data, select star from foo t, foo underscore t, okay, perfect. So now I have a whole thing. Okay, so here's what my mock foo looks like, and it's not real data, okay, and actually I can even, you know, because the select doesn't have to be the last thing, I could put here drop foo underscore t, and that probably is going to work. Actually, that isn't going to work. That isn't going to work because if I drop the table while the cursor is still, this statement will still be active, so I can't actually drop the table yet. I'll have to drop the table later. So I need another helper to do the cleanup. Great, okay. Turns out there's something here that can help you with that too, but fair enough. Okay, so this could work, right? This, I could, you know, I could believe that, and then let me see if that still compiles. Good, okay, yeah, so far so good. And if I look at x.c, that's, you know, pretty much what you would expect. It's a whole pile of code. But you can imagine this gets old, and you can also imagine this gets really old if there's lots of columns here. Okay, so one thing we wanted to do is make it easier to create a lot of dummy data, okay? And so we started adding some syntactic sugar features to the language. Okay, so instead of doing this, you can do this. You can say insert into foo t at dummy underscore seed, okay, and then we could do 1, and here we could do 2, okay. And what this does is it makes it so that everywhere there's a column that you didn't specify that is necessary to insert into the row, it will use 1 as the value for that column, okay? Or if it's a string, then the literal 1, or if it's a blob, then a literal that's blob 1, okay? So let's look at that. Okay, at WC 23, okay. Let's try that again. Okay, apparently I don't speak SQL anymore. You'd think by now I would know what was going on. Okay, and I need to do one more thing. Okay, good. Now, let me show you what that expanded out into. Here's our .c. Okay, and so you can see we got insert into foo of t, a, b, c, d, and values, question, 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 question. Okay, now first, let me just go back to the source code and notice that this bound the seed variable, seed, okay? And just before we did this, we said seed equals 1, and here we said seed equals 2. Okay, so this is basically inserting the seed value 4 times in each column. Okay, so that's great. And what's cool about that is it doesn't matter how many columns there are. Or even what the types of the columns are. But let's look at this x.sql again, and we'll see kind of what's going on. First of all, if you do this, okay, that's the same. This is always the same as listing all the columns. Okay? So, and if you list 4 columns, you have to list 4 values, right? So it's saying, by using this form, you'd be saying, I'm going to provide you some of the values. So for instance, okay, we could do, I want to specify the A, okay, and it's going to have a value of 22, okay, but for the rest use dummies. And here I want to specify the B, and it's going to have values of 44, but the rest use dummies. Okay, so let me do that again, okay, and then we'll look at x.c and look for 44. There it is. Okay, values 44. In fact, it's nicer actually to look at the generated code. You can see exactly what it converted this into. So there's a rewrite, okay, foo of t, a, b, c, d, A, B, C, D, both the same. Actually, not quite the same because the value you specified here was B. So your column stayed first, but it added A, C, D, and it added seed, seed, seed for those. Okay, great. Okay, and so you're getting those values. And likewise, okay, foo of T, A, B, C, D, 22. Okay, so the 22 and the 44 was preserved. Okay, so when I did this, the canonical syntax, which I of course didn't remember right away, it looks like this. You leave the columns blank and you leave the values blank, which basically says I'm specifying nothing, right? And that's different than if you do that, because that's the same as I'm specifying everything. Okay, all right, so, but of course that's kind of lame. We can do this, declare I integer not null, and then we can say set I colon equals 1, and then we can say while I less than 20, begin end. And for once, I'm going to remember to set I colon equals I plus 1. Okay, I'm not actually going to run this code anyway, so dummy seed I. Great. Okay, so if we look at that code, and we only have to look at the rewrite, and I zoomed right past it. Okay, here we go. All right, so dummy seed is I. Here's seed. Okay, seed, 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 seed. So seed will be set to I. We can look at underscore seed underscore equals. Okay, there it is. 0 first, and then I on each loop, and then insert bind, 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 step. Okay, so what that's going to do is give us all those lovely little rows. Okay, so here we're going to get 20 rows, and they're going to have all the right values. And actually, and the beauty of it is like, if it turns out next week we add like E, text, this is still good, right? This is still good. We're going to get a dummy value for E. It's going to be the string 0, 1, 2, 3, 4, 5, whatever. So it gives us some data. So that's fabulous. Okay, but we're still not done yet. I mean, this is still, there's a lot of boilerplate still here even. So So one thing we wanted to do was say, well, you know what? Well, actually, let me go back to the dummies. The other thing you can do here is you can say at dummy nullables, okay, and at dummy defaults. Either of these is possible. Okay, so this means even though a column has a default value, if it has a default value, you don't have to specify it. So it would ordinarily be omitted and you'd get the default value. If you add this, it means use the dummy value, the seed, rather than the default. Okay, great. So you can add that. You can mix and match some. Dummy nullables is the same way. If the column is nullable, if it's not specified, you get null by default. If you add dummy nullables, then even null columns will get binding. Okay, so and we could kind of so we can include that or not. Anyway, that's all covered in chapter 12 of the guide, so you could look at that. All right, so what else can we do here? Let's do some meta syntax. How about we do this? This is the first really exciting thing we can do here. Like t. Like foo. Okay, so this says I want the columns of foo right here. Whatever foo is, I want that. Okay, so wow, that's kind of nice because then I only have to change this, right? And if I add one to foo, foo t automatically happens. So isn't that exciting? So let me just do that. Okay, so here I'm gonna go nuts. F G. Okay, this is fabulous. Okay, x.c. Wow, look at that. Okay, look at all those rows, and then I'm gonna search for insert. Okay. A, B, C, D, E, F, G, of which I type none, value, seed, of which I type none, and boom, I still get 20 rows. Okay, and in fact, I could even do, here, let me make it a little bit more exciting. How about, I'm gonna add H is text, and it can be nullable, and I is text, not null, and J is a blob, not null. Great, let's try that. Or how about, yeah, blob will be boring. Let's do real. Blob will just look exactly like text. Okay. What does that look like? Okay, so here's our text. Okay. Column I, %d. That's the name of the text, and uses seed. So it's got this inline printf statement. Instead of binding seed directly, we get this inline printf statement. Okay, and that's a printf statement that will be evaluated by SQLite. And that's pretty much it. And look, all those extra columns got added. We changed nothing. Okay, we've got a bound null. We got a bound nullable and stuff. Here's all our readers. Let me look at the insert stuff. Okay, there's our multi-bind, just all increased. Okay, so, I mean, this makes it just a lot easier to go ahead and create those temporary tables and stuff, right? Okay, but what if you wanted something a little bit more flexible? Like, what if you needed to be able to not just do computed data? What if you wanted to insert rows into that table, right? Okay, that would be kind of exciting. Maybe you want to insert, maybe you want like a helper function to insert a row. So that your tests can, call your helper functions in various flexible ways. Okay, well, we can do that too. Okay, so here, let's make this a little bit more clear. Okay, how about we do a create proc, I don't know, let's call it make mock table. Okay, and so we'll just have this. Okay, and we can have this one, insert dummy rows. Insert, I don't know, let's call them, yeah, mock rows. Mock rows. Okay, great. So we have this. Okay, and then we might have create proc select mock rows. Okay, select star from foo underscore t, great. Okay, and then we might have then proc delete mock rows. Okay, and then here begin end drop table foo underscore t. Great. Okay, so that'll probably compile. Let's try that. Okay, where we got line 924. What are we missing? Create proc, no, none of that. Okay, I'm doing pretty good on these errors. Okay. All right, so now things are a little bit clearer. Here's delete, it's very obvious. Okay, here's our reader, and it's going to read A, B, C, D, E, F, G. Notice that these were expanded. I'll explain why we do that later when we talk about schema upgrades. Okay, then there's our fetcher, same as before. Here's the row set shape, same as we saw before. Notice it's all pretty complicated. Okay, and so we have these, you know, really helper methods. Okay, but like, what if I want to, you know, add some rows manually, okay, as well as with that thing? So let's look at this again. I want to write, okay, insert, you know, okay, so these are, you know, insert computed rows. How I mock computed rows. Okay, but what if I want to write this, like insert proc, insert mock row? Okay, what do I put here? Like I have to do some goofy thing, right? I have to say like insert into foo t. What am I gonna, you know, okay, well, okay, so I'm going somewhere with this. Okay, so I'm gonna put for the arguments, haha, like foo, okay? And then I'm gonna say insert into foo from everything, all the columns, from arguments. Wow, isn't that exciting? Okay, now with that little magic, okay, let's do the out again. And insert. Okay, so here's insert mock row. Look, we got all exactly the same columns as the table foo. Okay, we got all those arguments automatically, which is great because if one gets added, you'll get compilation errors automatically in all the tests that now need to add the new argument. Okay, if you're doing them manually like this. So we got all those columns and all the types, and they're all right, and they're all in the right order. And then we inserted all of those columns and used all of those values. And all we did was have this convention that the arguments have an underscore at the end of them. So that's, you know, pretty fabulous. And we can actually do more. We can frequently pass around these bundles, right? So for instance, and I don't want to get too crazy because this video is already running pretty long, but let me make a different procedure to show you that you can actually continue doing some of the stuff here. So we have insert into foo of t from arguments. What about if we did, you know, create? I'm gonna copy this. Great. Insert into foo of t from arguments. Okay, and so that matches. We can also do this. Call proc foo insert mock row helper from arguments. Okay, great. And where we got here, 31. What did I do wrong? Okay, I'm obviously missing I have a mismatch something or another. Begin proc helper like foo from arguments. No, there's no call proc, just call. Notice I don't even look at the error. I could have just gone to line 31 like it said, but just rather just go. Okay, so what was the point of all that? Well, it's kind of a stupid helper because it does all of the work. But the whole point of this is to say, here's a helper, okay? It's getting all the args, okay? And the guy who called it, insert mock row helper, likewise, okay? Just forwarded everything from his args to the call, okay? And actually, you can even do subsetting. So, for instance, here, let me make it a little bit different. Now it's a little bit goofy, but okay. Insert into, and I think I'll stop after this. But let's say that I only want some of the columns, okay? Like, let's say I want just A, B, C, D. I could say create temp table shape, and then I'm going to do this. Okay, so I just want A, B, C, and D. To make it clear, I'm just going to give it the name ABCD, okay? It could be any name. And this table doesn't even have to exist. This table doesn't really exist. it's just a shape. There's other ways to define a shape too, but this is probably the most straightforward one. Okay, so in the helper, I'm going to say like ABCD. Okay, but that's not enough, so I'm going to say dummy seed. Okay, and I'm going to, I don't know, how about we take the seed? Take the seed, seed. Perfect. Okay, and here I'm going to say long integer seed. Okay, perfect. Now in macro helper, I'm going to do from arguments. Ooh, look at this, like ABCD. Okay, so just the ABCD arguments, okay, whatever they are. Now, as it happens, they're A, B, C, and D. And then for the seed, I'm going to say, I don't know, how about E? Okay, E will be the seed because E is a suitable integer. Which is kind of a weird way to do it, but okay, so I got all these foo things, but to this helper, I just passed ABCD. Now I could have had a different helper, okay, you know, which was like EFGH or whatever. I mean, this is a stupid name for the type, but presumably this is some subtype and this is some other subtype, and the main type is a composite of both of those. So what this is saying is I can grab the arguments that match certain names and insert them in order or call them along in order. Okay, and that actually works all over the place, right? Okay, perfect. So from arguments like, and so at this point, okay, this isn't going to work because there is no EFGH, but that should work. Okay, what did we do? I'm going to actually look at the line number. Long, okay, seed long integer is how we do this in SQL, Rico. We don't do long integer seed. Okay, what do we do here? Too few arguments, 34. Okay, 34, 34, 34. Insert into foo of t. Oh, look at this. Like ABCD. This gives us the columns of ABCD. Okay, because we want just those columns. Not all of the columns of foo of t. Now, probably this would have been an ABCD record in the first place if this was a real example, but okay, whatever. In this case, I kind of have to fake it, but that's good. It gives me this thing. Okay, so where columns go, I can specify a shape. Where arguments go, I can say from arguments, or I can get them from a row, a cursor, something like that, using the like construct, and I can subset them if I want. Perfecto. Okay, so okay, what do we got here? It must be a non-nullable integer. 34 integer not null. Strong typing while you wait. Okay, what did we do? 34 long seed long integer not null. Dummy seed seed. Oh. What's the type of E? Oh. Let me look at that again. Okay. Seed expression must be a non-nullable integer. Procedure had errors. Okay, so x.SQL line 34. Insert into foo. Dummy seed. Seed long integer not null. Boy, that sure looks like a long integer not null to me. What if I just put 1 here? Name not found E, 39. Oh, okay, so this will be E like so. Okay, and seed expression is must be a non-nullable integer. Huh, okay. Apparently it can't be a long integer. Well, all right. I thought long was actually what it needed to be, but apparently I'm wrong. Okay, well, there you go. Even I get this stuff wrong. Okay, so there's our integer. And now we can look at this code. Seed. Okay, so we've actually done a pile of stuff. So here's the little helper, okay? Notice that it's taking A, B, C, D from the shape, okay? And we typed none of this. And seed, 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 seed. And some of them are turning into strings, and some of them are turning into presumably reals. Didn't we have some reals in here somewhere? A, B, C, D, E, F. Oh yeah, J is a nullable. Okay, great. But we're binding an integer, even though the column's a nullable. Right, okay. Because even though, search for the insert. Right. Even though that column, even though the column is going to be, even though the column is real, then the thing we're binding is actually an integer. So that's fine. But let me see if I have this right. X.SQL J real. I'm not seeing J. Well, I'm a little surprised that there's no J. Why is there no J? Don't you love unscripted demos? Okay, let me look at that again. Temp table ABCD. Insert into foo of T and foo of T. Okay, foo of T, where's foo of T? Create temp table foo of T like foo. Okay, so that's our thing, and it should be exactly the same. Okay, so there should be a J. Oops. Don't need to do that. Okay, there's our J. There's the J binding. Okay, what's going on with our insert statement though? A, B, C, D, E, F, G, I. What's in foo of T? Oh, because it's nullable. There you go. Okay, they're nullable, so they're optional. Okay, there you go. So now, okay, null dummy seed at dummy nullables. Insert A, B, C, D, E, F, G, H, I, J. There we go. Okay, so those values were getting skipped because they don't have to be specified because null is legit. So by putting dummy nullables, it forces the issue. So we get the seed in all of the columns, including the ones that were nullable columns. And we would have had exactly the same problem with dummy defaults. And even though I had just said that. Okay, but notice that we're still binding int32s. The seed is always an int32. And we're still binding int32s, even if it's a float that we're ultimately gonna store, because all that's happening is an int is being replaced for this value, but an int is valid as an insertion into a float column, so it doesn't even try to convert the int. SQLite will convert the int for its storage, and that'll be that. Okay, that's more than enough. We've been going for some time now, so just going to stop here, and before I do that, I'm just going to review this little program to kind of give you a sense of what's going on. So here's a crazy table that we presumably have to work with. Here's something that gets the value, okay? Here's something that makes a mock table, and we don't have to have any maintenance problems because we're using the like syntax to clone all the columns. Notice that we won't clone all of the foreign key constraints and all that jazz, just the columns. Which is actually very useful for this, because typically what you're doing here when you're making the shape is you're redeclaring a comparable type, not a comparable table in context, and you typically want it out of context so you can put any value you like anywhere you like for fake data purposes. Then we said, well, here's something that is like some of the columns that we might want for whatever reason. This table will probably never be created in schema, okay? We would never actually make this table with a create statement in a proc. So here we are inserting into our temporary table, and we don't even need to know its shape. We don't need to know what's in A, B, C, D. We just get those arguments, and we don't need to know what the column names are here. I mean, obviously they're A, B, C, D, but and then we just get those from our arguments. Notice this takes exactly the right number of arguments, so you'll get an error if you need 4 arguments and there aren't 4. And this gets them in order. We could have done this too, from arguments like A, B, C, D. Okay, if we do that, then we get them matching by name. So the names have to be A or A underscore B or B underscore C or C underscore D or D underscore or whatever the columns are of this thing, right? It might have been better if I'd not called this A, B, C, D. You know, it doesn't really matter what we call this. This is just some, you know, ABCD plug. Okay, so it's, you know, something that has some columns, some of the columns. Okay, so same, this will work identically well. So this gets us the plug columns, the plug arguments by name. And here, let me make sure that actually works. Yep. Okay, and here, let me make it a little bit different. Okay. Plug, just to make it clear. I was trying to do a summary and then I got distracted, but okay, let's do plug here. To make it more complicated, I'm going to go DACB. Okay, great. My commas are messed up. Okay. Okay, so DACB. Okay, so it's expecting the columns in order DACB, and that's exactly what it gets, even though the arguments actually came in. Well, here they came in DACB, right? Because they matched the type. But actually, they didn't have to. All right, well, now we're getting even more complicated, but like plug. Okay, I could have said here. And it would still work, right? Because it's going to match the args by name. And in fact, I could have done that here as well. Well, here I have the arguments are like foo, so they're actually in a different order, right? So insert mock row. That's a good, we don't actually have to make that edit. If we look at insert mock row, if we look at the call to the main one, okay, this one has got the arguments in in order. Oh, there's the helper. So we want insert mock row, not the helper. Insert mock row. Okay, the arguments are coming in A, B, C, D, E, etc. Okay, and notice that when we call a mock row helper, we get DACB, and then we pass E as the seed. Okay, so they got reshaped according to the plug shape, which has them in the order DACB, and then the other thing is expecting them in the order DACB, and that's exactly what we get, which is also the order that we want to insert them. But even if we had rejiggered them, you know, it still would have worked out as long as we matched the prototype plug. So it's really kind of hard to get it wrong, and you sort of in this way get by name calling. Okay, let's just quickly finish the review, and so I can wrap this up. Okay, so insert mock row. This is the helper. It does some wonky thing. This is a stupid example of a helper, right? Presumably we would need, you know, more, either more here or more here in order for this to even make any sense, but that's fine. For an example, we're just showing that you can forward arguments and you can forward pieces of the arguments. You can actually even do this. You could do this more than once, right? You could also have from arguments like, and then something else, you know, something else, okay? So if you had two structures, you could say, I want the arguments that match this thing, and then the arguments that match this thing. And likewise, you could have declared them here, okay? Like plug, bouncing all over the place. Right, so here we could have said, like, you know, second thing, whatever that is. A second thing. I don't know, it doesn't matter. Some second thing. So you can keep doing this, it's just a piece of it. Okay, I'm gonna go back to all that. From arguments. Okay, so here's our little helpers. Then here's one that does it by computation. So we could add as many rows as we wanted. This is just a bulk inserter, and it's just using these dummy forms as we saw. We're usually using the dummy form up here because we're doing a subset of the columns. You can easily add lots of columns this way. And then you can pull rows without knowing what they are. Again, if foo t changes, this still works, and most getters would be unaffected. The getters will still match the signature. And then you can add validations for the new columns, and delete still works. The beauty of it is, since these things like creating the, you know, this kind of inserter, this kind of inserter, this kind of forwarding, you know, since the code is literally the same, right? Because we just use, these like forms, right, in the calls. Oops. We can actually make helper code that does this. And next time, here, I'm just gonna get out of here before I mess up even more. Next time we're gonna look at the option -rt test helpers, which actually creates automatically for you exactly the kind of methods that I just showed. And so starting from a procedure, you can get automatically a thing that makes a temporary table and so forth. And this is all, that stuff is covered in chapter 12. And we will be doing a video on chapter 12 stuff next time. All right, thanks so much. Didn't mean to go a whole hour, but there it is.